Hi, year 11s and 12s. Today we're looking at the second video in our photosynthesis PowerPoint, which is a HL topic of the IB diploma for biology. This is unit 8.3, the last unit for topic 8 before our next test, which will be early on next term. So, in this one we're looking at step 1 of photosynthesis, which is our light-dependent reactions, and let's begin. So, the products of light-dependent reactions, light energy, obviously because we need light energy for light-dependent reactions, will be converted into chemical energy in the form of ATP and reduced NADP. Now this is done in reactions that involve light. The purpose of doing this is that ATP and NADP, which are reduced in these light-dependent reactions, will serve as energy sources for the light-independent reactions that occur in stage 2. Now when this happens, these reactions that we're talking about, they will occur within specialized membrane discs called thylakoids, which we talked about in the last video, and they'll occur in 3 different steps. So the first step is the excitation of photosystems by light energy, then the production of ATP via electron transport chains, and the reduction of NADP+, and the photolysis of water is our third step there. We're going to look at each of these steps. So the very first step, step 1, the excitation of photosystems by light energy. So photosystems are a group of photosynthetic pigments, such as chlorophyll, that are embedded within the thylakoid membrane, which we talked about in the first video. Now photosystems are classed based on their maximum absorption wavelengths. So we've got photosystems 1, which will absorb wavelengths of up to 700 nanometers, and photosystems 2, which will do 680 nanometers. Okay. Now when they absorb the light energy, that causes delocalized electrons within those pigments to become energized or excited, hence excitation of photosystems. And those electrons will be then transferred to carrier molecules within the thylakoid membrane. So we're essentially reducing them. Remember, reduction is gain of electrons. So we're transferring those excited electrons to carrier molecules, reducing those molecules. Okay. So that's step 1. Light comes in, goes into our thylakoids, and starts to excite the electrons inside the photosystems, which causes them to be transferred to carrier molecules within the thylakoid membrane. We then move on to step 2, which is the production of ATP via a type of electron transport chain. So excited electrons from photosystems 2, which is the ones that's dealing with 680 nanometer wavelength of light, are transferred to an electron transport chain within the thylakoid membrane. As those electrons are passed through the chain, they lose the energy they've gained from the light, which is then used to move hydrogen ions into the thylakoid. So we can see down here, okay, as the electrons move across the membrane, we're getting hydrogen ions moving across, okay, moving these hydrogens into the thylakoid themselves. This builds up the proton force, so proton motive force, within the thylakoid and creates our electrochemical gradient. And our hydrogen ions will then return to the stroma with the proton gradient via ATP synthase, which is chemiosmosis, which we talked about last week in respiration. ATP synthase will then use those hydrogen ions to catalyze the synthesis of ATP, so making ATP from ADP and phosphorus. This whole process is called photophosphorylation. Now last week we talked about phosphorylation and oxidative phosphorylation. This one's called photophosphorylation because unlike the last one with oxidative phosphorylation where it was because of oxidation, this phosphorylation has occurred because of light, and it's all because of the light coming through the chloroplasts. And hence, because light's involved, it's photophosphorylation, so we're creating ATP from light, photophosphorylation. So in step 3, we're going to start by talking about the excited electrons from photosystem 1. Now I know we finished the last slide by talking about the de-energized electrons from photosystem 2, and we will get back to those, but right now we know that they've been taken up by photosystem 1, but we're not going to talk about them right now. We're talking about the excited electrons from photosystem 1 that happened in step 1, the excitation of photosystems. So those excited electrons from photosystem 1, they can be transferred to a carrier molecule, and we use that to reduce NADP plus into NADPH. Okay. We need NADPH along with ATP, which we created in step 2, for our light-independent reactions, which we're going to talk about in the next video. Okay. Now, once the electrons from photosystem 1 are transferred to these carriers, we need to replace them, and we replace them with de-energized electrons from photosystem 2, so that's where we talked about these de-energized electrons here, once they've been gone through ATP synthase, etc. Okay, we're replacing these back into photosystems 1. Once they're lost, they're replaced by electrons released from water via photolysis, so we're keeping these electrons replaced constantly. Water is split by light energy into hydrogen ions, which we use in chemiosmosis, and oxygen, which is released as a byproduct. That's it for light-dependent reactions, and in our next video we will look at light-independent reactions.